Welcome back students. Let us discuss in this video an overview on testing the significant difference between two dependent or correlated means. Overview. Formulate the null and alternate hypothesis. The null hypothesis H0 states that there is no significant difference between the two dependent means, while the alternative hypothesis H1 suggests that there is a significant difference between the two dependent means. Choose an appropriate test statistic. The choice of test depends on the characteristics of the data and the assumptions being met. Commonly use t-test for dependent means. Paired sample t-test. This parametric t-test is appropriate when the data is normally distributed and the difference between paired observations are approximately normally distributed. It evaluates whether the means difference is significantly different from 0 or not. Wilcoxon rank test. This is a non-parametric test which is suitable when the data is non-normal or the assumption for the t-test are not met. Here one can choose the desired significance level such as 0.05 or 0.01, that is 5% or 1%, which determines the threshold for rejecting or accepting the null hypothesis. Computation of test statistic. Perform the chosen statistical test on the paired data to obtain the test statistic. The test statistic quantifies the difference between the paired observation and assesses the evidence against the null hypothesis. Determining the p-value. Here one can calculate the p-value associated with the test statistic. Compare the computed value with the p-value. If the p-value is smaller than the chosen significance level alpha, typically 0.05, you may reject the null hypothesis. This suggests that there is a significant difference between the dependent means being compared. Interrupt the result. If the null hypothesis is rejected, it indicates that there is evidence of a significant difference between the dependent means. If the null hypothesis is not rejected, it suggests that there is not enough evidence to support a significant difference. Remember to consider the assumption of the chosen test, such as the normality of the differences or the appropriateness of the non-parametric test. Additionally, you can keep in mind the replication and effect size estimation can provide further insights into the significance of the observed difference between the dependent means. Example. Here a drug is given to 10 patients and the increment in their blood pressure were recorded to be 3, 6, -2, 4, -3, 4, 6, 0, 0 and 2. It is reasonable to believe that the drug has no effect on change the blood pressure. Here one can apply the t-test based on paired observation is defined by the following formula: t equal to d bar minus 0 divided by s into root 10 or t equal to d bar into root 10 divided by s, where d bar is the mean of the differences, s is the standard deviation of the differences. The value of s is calculated as follows: s equal to square root of summation d minus d bar the whole square divided by n minus 1, or we can use an alternative formula s equal to square root of summation d square minus n into d bar the whole square divided by n minus 1. It should be noted that t is not based on n minus 1 degrees of freedom. Solution. Let us take the null hypothesis that the drug has no effect on change of blood pressure. So we can take the alternate hypothesis as that the drug has an effect on change of blood pressure. So the values are given here. The summation d and summation d square is summed up. Then we have d bar equal to summation d by n, that is equal to 2. By using the formula we get s equal to 3.162. So t equal to 2 into root 10 divided by 3.162, that is equal to 2. Here the degrees of freedom nu equal to n minus 1, that is equal to 9. So the significant level of t value at 5% is given as 2.26. Here the calculated value of t is equal to 2. is less than the table value 2.26. The hypothesis is accepted, hence it is reasonable to believe that the drug has no effect on change of blood pressure. Let us summarize what we have learned in this video. In this video, we gone through an overview on testing the significant difference between two dependent or correlated means with an example. Students, we continue in the next video. Thank you.